There we go. Move your legs around so we're in a good position. Move them right around. Very nice. So let's see what you'd like to do today. We could do some more reading Macbeth that we started, or we could do something about nature and maths linked, how they link together, or we could do some science. I found something interesting in a science magazine. What would you like to do? What would your choice be? Go on. ID. C. H. O. Come on then. This is good. O. O. Keep it going, come on. S. I choose. A. A. I. N. T. INT. Come on. INT. E. R. E. S. T. I. N. G. I choose. Interesting. T. O. T. O. A Q wouldn't make sense, I don't think. So I choose, I think he meant Anne. Interesting. T-O. One. P. I. See, I choose an interesting topic. Well, I think I have offered you a couple of interesting topics. Maybe, what about prime numbers in nature? That is interesting. Or, I'll tell you what the other one was. This was about, oh yes, the seasons and our human biology. So we've got prime numbers and nature, or the seasons and human biology. You could just show me P or S. Which one would you choose? P. Okay, let's have a look at that one. So we're going to look at prime numbers in nature. Prime numbers in nature. I can get my notes. I found this information in this new book that I've got, just for your own interest. Look, this new book is called How to Free Your Inner Mathematician, and there's lots of examples about maths and maths all around us. So, to begin with, have a look at this picture. Look, what can you see on it? There's a wing, eyes, legs, another leg. So, what is that picture? I, T, it, L, O, O, K, it looks, L, I, K would make sense. Looks like, looks like, T, T, okay, go on. Y, go on. After the Y would be P, E, O, go on. F, go on. Yeah, go on, I think you're right, yeah. Looks like a type of, just missed it, yeah. No, go on, I'm going to help you with that handbiting. Come on, type of what? F, L, Y, yes it does. I'll just hold it up to the camera. There it is, everybody. It looks like a type of fly. Looks like a type of fly. Okay, I'm going to tell you the name of this kind of, it is an insect, you're absolutely right. I'm going to tell you the name of it because I've never heard of it. It's called, I don't even know how you pronounce it, so I'm just going to spell it out and then we'll pronounce it as best as we can. A cicada, C-I-C-A-D-A, C-I-C-A-D-A. So it's called a, and you can, that was just an impulse to stand. It's called a C-I-C-A-D, and all the way over A. Yes, cicada. What on earth has this got to do with prime numbers, you're probably asking? Well, we'll get there. Just bear with me. So, first of all, let's just think about nature and animals and how they evolve. So, all sort of animals and insects, all animals and insects evolve in ways to kind of enable their survival. They evolve to enable survival, to enable really survival of their species. So they all E, B, O, L, V, E, they all evolve. S, O, so, T, H, E, Y, so they all evolve, so they, yeah, K, A, N, can, S, U, R, V, touch it, touch it, touch it, push, 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 after the V, I, good, V and E, they all evolve so they can survive. So let's have a think of some examples, some quick examples of how you can either pick an animal or you can pick an insect, how it's evolved to help it survive, maybe to protect it from predators. Give me one example. One example would be what? CAMOFLAUGE. Okay, yeah. CAMOFLAUGE. Oh, that's a good example. Yeah, how many creatures use, I don't even know if that's his, but use camouflage. I think it might just be AGE. We'll check later. Use camouflage as a way of protecting themselves. Could you give an example of one that you think is camouflaged quite well? Any example? And maybe one that we've seen. Where would you think? Which ones have we seen? D. Oh yes. E. R. Oh yes. Deer. When we've been out sometimes to the National Trust places, we've seen deers, and when they're sort of lying in the field with the brown and stuff and the trees and the long grass, you don't notice them. Even though they're big creatures, you hardly notice them because they kind of camouflage into the background, don't they? So another good example of one that uses camouflage would be a moth. A moth is like a browny colour, and if the moth is on a tree, then actually it just, sometimes some of them just blend in perfectly to the tree and you can hardly see them. And the other thing that moths do is that when they're on the tree, the moth, if that is, say that's the tree trunk, then the moth makes itself sort of almost perfectly flat. So imagine that's the moth. So then when it's on the tree, it's perfectly flat. So it's the same colour and it's got its wings spread out perfectly flat. So it's very hard for any predator to actually see it. So yeah, so moth lies flat on a tree and blends in. So it's not just the colours, but also that helps to camouflage them and protect them. Also the S, H, SH, A, P, E, so it could be the colours, it could be the shape, like the moth lying flat. Yeah, any other ways that animals have adapted to protect themselves from predators? Any other ways? P, O, I, S, O, N, O, U, S. Oh yes, that's a good one. Oh, that's a very good one. They can make themselves sort of poisonous, can't they? Do you know any examples of ones which might have a poison in? S, N, A, K, E, S. Snakes. You want to carry on? V. Oh yeah. E. Very good. V, E, N, Ven, O, and after the O would be snake, venom. Yes, I like that example. It's very good. Keep your hand down. I'm keeping hold of it. Snakes, venom. There's also certain types of frogs that have got poisonous kind of venom. So yeah, they make themselves poisonous, or they might have like a protective kind of shell. They might have a protective shell, or sort of like, you know, if you think about cactus, they've got prickles on them to discourage animals from eating them. Protective shell or prickles. Name an animal that's got a protective shell. T, U, R, T, L, and a turtle has a protective shell. Yes, E.g. turtle. And something with a prickle. H, E, D, G, E, H, O, O, G. Yeah, hedgehogs. Hedgehogs. Oh, keep that hand down. You're doing so well. So proud of you. Hedgehogs have the prickle. Now then, but have a little look at this picture again that we looked at. This is the cicada. Ooh, does this look like it's got any way of protecting itself? What do you notice about it? Just touch out. So, oh yeah, oh look at that. Yes, it's got eyes there that stick out. It's got sort of very what look like fragile wings, hasn't it? So it's a bit of a strange one, this one. Does it look as if it has any way of protecting itself? No, it doesn't, because it's got big red E, Y, E, S. It's got big red eyes. So if there was a predator that wanted to eat it, oh look, there it is. I can see it easily. Munch, 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 and it's got fragile, looks like quite a fragile body, looks like no protective shell. It doesn't look like there's an obvious way of it having any poison. So, how would this species manage to survive if it's so easy to eat? That's the problem. Actually, it's got a sort of quite a chunky shape. It stands out. It's got the prominent red eyes. So it is what? E, A, S, Y, easy. T, O, 2, S, E, E. Easy to see, yes. Easy to see. So how has that species managed to survive? How come it's not just being eaten? Oh, this is where we get a little bit of maths coming in. So first of all, it has two defence strategies. Number one, predator, there we are, satiation or satiation. Oh, what does satiation mean? What does satiation mean? S. Go on. A. T. I. S. Go on. Oh, you should have stopped that yourself. Tell yourself, I'm not going to do that. I-S. F. I-E-D. Satisfied. Hang on. Satisfied. In what way are they satisfied? In what way are they satisfied? F. U. L. L. Full. U. That's good. Full up. Yes. It's a good way of describing it, actually. A nice, simple way of describing. It's like when you've eaten a really big meal and you're just absolutely full up. You don't want any more. So how on earth does that work? Well, listen to this. Not all of these, there's different types of these cicadas, but we'll just talk about this one type. There's one type of them, and they emerge from hibernation rarely. They only emerge in 13, there's one type that emerges in 13-year cycles, and there's another one that emerges every 17 years. Okay? But when they emerge, they come out in vast numbers, and they're all synchronised, so they all come out at the same time, so that anything that wants to eat them can eat as many as they want, but because there's so many of them, it can't eat them all. So many, but not all, are eaten. Okay? So just put that into your own words. A-L-O-T, a lot. E-M-E-R-G-E, a lot, emerge. B-U-T, but you control it yourself. A lot, emerge, you stop it, but T-O-M-A-N-Y-T-O-E. Come on. E. After the E would be A and T. But too many to eat. Yes. But you stay. Too many to eat. So that loads of them come out, but too many to eat. The interesting thing is, you see, the predators have life cycles between, so the predators, we'll call them P, have life cycles between 2 to 5 years. Okay, so if they're present for what they call a bloom is when the cicadas come out, they will not be present for the next one. So what we're actually saying is that their longer life cycle is a kind of a defence mechanism. So their life cycle was how many years? Could be 1, 3, some have a life cycle of 13 and some have a life cycle of 1, 7. And the predator's life cycle is between 2 and 5, yes. 13, 17, 2 and 5. Now then. So here's a question for you. If the defence mechanism is due to having a longer life cycle, why don't the cicadas just have a life cycle of 6 years, which is longer than the predators? Why is it 13 or 17? Do you think that's just random, or do you think that there's going to be a logical reason for it? What's your view? A M G, go on. U would be good. E S S I N G. I'm guessing. Hang on. guessing, sorry I should put that on to silent. I'm guessing I-T-I-S. It is T-O-D-O to do, W-I-T and H. Very good. I'm guessing it is to do with P-R-I-M-E prime N-U-M. Yes. Oh, hang on, that was a bit of a slide. Take a little drink. Oh, take a little drink. I'm having a drink as well. To do with P-R, go from there, I-M-E prime, N-U-M-B-E-R-S prime. Numbers, that's because I introduced that in the title, didn't I? Yeah. And you're right, it is. Let's have a look. So, we'll just do a little chart. So, we'll put P for predators and we'll put C for cicadas. So predators. Let's just do an example. Let's just say a predator has a life cycle of 3 years. So, we'll start off with 3. The next number on the list would be, if it was every 3 years, next number would be 6, and then it would be 9. So we'll do a couple of times, so we'll list them. 3, 6, 9. Go on. 1, 2, 12. 1, 5, 15. 1, 8, 18. So 12, 15. We're just going to go to about 24, okay? 18 then. After 18 would be 2, 21. Then would be 24. Yeah, so we've gone to 24. So the 3-year life cycle, they're going to appear year 3, 6, 9, 12, 15, 18, 21 and 24. The cicada, let's just say, for the sake of argument, it had a 6-year cycle. If it had a 6-year cycle, it would start in year 6. Then the next year it would appear would be year 1, 2, 12, and then 1, 8, and then 2, 4. Yes. So 16, 12, 1, 8, 2, 4. Now then, if we look, this correlates. So this would mean, let's look at the matches. I'm going to hold your pen. So we're going to start on number 6, where the predators are. Are the cicadas there? Yes. So we'll draw a line across, all the way to number 6. Now we'll go down again. Oh look, year 12, we'll go across the other way. Year 12, they come out. Oh look, yes, the predators are there again. Year 18. Oh yes, they're there again. Year 24. Oh yes, they're there again. So in that 24-year cycle, how many times would the cicadas encounter their predators? In that 24-year cycle it would be, how many? 4, yes. So let's put that. 4 times in 24 years. That was if they had a 6-year life cycle. Okay, but listen to this. The ideal life cycle for a cicada would be, and this is where the maths comes in, a number greater than 5, which is the predator life cycle, but which also has no divisors other than 1 or itself.
Yeah.
And that definition is what? A number that has no divisors other than 1 or itself is what? P R I M E, a prime. N, we just press in U M B E. Oh yeah, that equals prime number. So we'll look at the example again. Here we are. Let's look at the example again. We'll go beyond 24. We went to 24 before. Let's go beyond. So we start at year 24. So this is the predator with a 3-year life cycle. 24. I'll fill some in and you can fill some in. Here we are. Come on. 24. 27. We'll take it in turns. So, down you go. After 27 would be 3, 0. After 3, 0 would be 3, 3. Then would be 3, 6, 3, 6. I'm going to go for the next one, which would be 3, 9. Next one would be, this is easy, 4, 2. Then there'd be 4, 5. Then would be 4, 8. Then would be 5, 1. Okay, we'll just go to there. Now let's just pick, this time, if the cicada has a 17-year life cycle. So we'll start off with 17 and let's match the numbers up here. So after 17 would be the very first time that it would appear.
Yay.
17. Then what would be next? Next time would be 3, 4. Then next time would be 5, 1. 5, 1. Oh look, look, look. How many times does it match? If it has a life cycle of 17 years, 5, 1, 5, 1. Let's join it together. Let's draw a line. Okay, so look. So in this example, with a life cycle of 17 years, it is only every 51 years that it has to fend off this predator. So that shows why the longer, the 17-year life cycle minimises the number and variety of predators at any one bloom.
I see.
More effectively than a smaller non-prime number would. So what do you think about that? What do you think about that? I-N-T-R-E-S-T-I-N-G. Interesting. Oh, good. And I found it quite interesting, really. And it also gets you thinking, really. You know, it gets you think about, well, what could we learn from the cicadas' life cycles? You know, we often have sort of quite regular fixed routines and ways of doing things, whereas what they've done is come up with something which is a bit more unusual, and that has enabled their species to survive, so or to thrive. So what could we learn from that? A Y B. After the B would be, not in your mouth, after the B would be, maybe D O T H I N G S, do things, A T act. That's good. What could we learn? We could maybe do things at D I F F E R E N T, at different, T I M E S T T. We could maybe do things at different times, T O S E E to C H O W to see how, to see how, come on, I T it, to see how it, F E E L S to see how it feels. You're right, because I mean, sometimes you get into such a habit of doing things at a particular time that maybe just swapping things around a bit and doing things at a different time might make it easier. It might make it, we always do your RPM sessions like sort of now, first thing in the morning. Maybe we should try doing one in the evening. See how it feels, just for a change, yeah? And it might be easier. You might find that you're more creative or able to do things differently. So is there anything that you would like to try doing at a different time, just out of interest? Just out of interest to finish. Sit down. Anything that you'd like to try? I N E E I N E E. Go on, just finish it off. Tell me. D. I need. T O. I need to. I need to what? B. E. I need to be. A. I need to be a. Come on. B. I. T. Bit. M. O. R. E. A bit more. F. L. E. X. Type I. That was good. I. So well. This is so good. I. B. L. E. more flexible. Any more? Any more? T, T, H, I, S, this, I, is, this is H, A, okay, R, D, this is hard. Take that one down first, and then the other one will follow. Oh, take that one down first, then the other one will follow. Look, it's all finished. This is hard. Go on, just finish off the sentence. This is hard. F, O, R for M for me. T, 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 O, D and O. Okay, this is hard for me to do. Okay, I need to be a bit more flexible. This is hard for me to do. Right, well, we could try just doing one thing differently and see how it goes. All right, we'll have a little think. You can have a little think about what you'd like to try. Now, have you got any more to say now, or have you finished? M or